Okay, so I'm recording. Okay, there's a question in the chat. Arnold, you have a question? Please go ahead, ask your question.
Good afternoon.
Good afternoon.
Please, I just want to ask if that will be possible to run ROS on Windows.
You cannot run ROS 1 on Windows the way that we are using it in this competition.
Donc la question était de savoir si c'était possible de run ROS sur Windows, et Kenny a dit que ce n'est pas possible d'utiliser ROS 1 sur Windows.
You can run ROS in a virtual machine on your Windows. You can run
Yes,
ROS
I know.
in a Docker container on your Windows. You can use WSL to have a Linux instance on your Windows, but you cannot run ROS directly on your Windows.
Thank you very much. But it's okay with me. I just want to know if that will be possible or not. Thank you very much.
You're welcome. You're welcome.
Donc, n'est pas possible pour vous de faire fonctionner ROS sur votre appareil Windows, à moins que vous n'utilisiez une machine virtuelle. Donc, vous pouvez faire fonctionner WSL, Docker Containers, mais vous ne pouvez pas faire fonctionner ROS sur votre machine Windows, à moins d'utiliser une machine virtuelle.
All right, awesome. So we have two introduction to ROS, I'm sorry, not ROS, to robotics workshops, one today and one next week.
Donc, nous avons deux introductions à la robotique cette semaine, un pour aujourd'hui et l'un la semaine prochaine.
Then 2 weeks after that, we would do a workshop on MATLAB ROS, how to use MATLAB with ROS. That will be led by one of the MATLAB engineers.
Donc, après ces 2 semaines, vous aurez un autre atelier sur MATLAB et ROS. Et ce ne sera pas Kenny qui va gérer le meeting, mais ce sera quelqu'un qui travaille à MATLAB.
And then on the 29th of April, we will have a workshop focusing on computer vision.
Et le 29 avril, vous aurez un atelier sur la vision à ordinateur.
Okay. And then in the month of May, we will have 2 very exciting panel sessions where we'll be inviting robotics experts in the field, in academia and industry from all around the world to share their experience in robotics and specifically in agricultural robotics in Africa.
Et donc, d'ici le mois de mai, vous aurez un panel où vous rencontrerez des personnes influentes dans le domaine robotique agricole en Afrique qui vont partager leur expérience.
All right, and then we will be ending phase 1 by the 30th of May.
Et on va terminer cette session le 30 mai.
Okay, so there's a lot of activities, many Saturdays to spend learning and engaging and building network. If you're not able to attend any of these sessions, please, you can always catch up by going on the website and watching the video. If you have questions, you can always come on Slack and ask questions after you watch the videos.
Donc, si vous avez des problèmes de difficulté à accéder aux réunions, vous pouvez toujours voir, regarder dans le site les réunions qui ont été enregistrées, et ensuite, si vous avez plus de questions, vous pouvez venir sur Slack et vous aurez vos réponses.
All right, so anybody have any questions about this timeline?
que vous avez des questions.
Okay, with absence of question, if you have question, you can always also ask, but I will move on. But always happy to take your questions. Okay. Okay, so there's a question in the chat. Can I install ROS in Kali Linux? I'm not sure what Kali Linux is. If it's a flavor of Linux similar to Ubuntu, no, you can, well, I guess you could, but we are not supporting, we're only supporting Ubuntu. Okay, we're only supporting the Ubuntu Linux distribution. So please, we will ask you to install Ubuntu Linux on your computer and use that with ROS. All right.
Donc la question c'était de savoir si c'était possible d'installer Kali Linux sur son ordinateur, d'installer ROS sur Kali Linux, et il a dit que c'était pas possible, c'était mieux d'utiliser Ubuntu.
All right, you're welcome. All right, so I'm very excited about this workshop. It's the Intro to Robotics, Part 1. I slept very late last night to prepare this for us, so I'm very excited to have this nice workshop with you. So we'll go ahead and start. This is the outline. It's going to be quite fundamental, but I think it's very important concepts that I want to share with you, okay? Starting from what is a robot, we can look at different types of robots, understand the core components of robots, and then have an example on using ROS to control a robot.
Donc, le sommaire de cette introduction à la robotique sera de connaître qu'est-ce qu'un robot, les différents types de robots, et quels sont les éléments essentiels que compose un robot, et comment l'utiliser avec ROS.
All right. So we'll just go ahead and start. What is a robot? I think that this is an important question to grapple with. I wonder if anybody in the chat wants to, or maybe you want to unmute yourself and try to give a definition of a robot. What is a robot?
Quel est selon vous un robot? Vous pouvez ouvrir votre micro et donner une réponse.
Anybody want to share a perspective on what is a robot? Nobody? Okay, Barnabas, go ahead.
Yeah, in simple terms, you can say a robot is an automated machine that can carry out tasks with little or no human intervention.
An automated machine that can carry out tasks with little or no human intervention. That is a very nice definition, actually. Thank you. And yes, Somo?
I wanted to say almost the same as Bavanas, but a robot is like a machine able to perform tasks autonomously.
Okay, so able to perform tasks autonomously. Okay, so that's automated machine that can perform tasks autonomously. So those are some main themes or concepts that you are mentioning, which are important. All right, that's all very good. Actually, it's in the industry, it's quite difficult to fully describe what a robot is, and most of the things you've said are all correct. But in the industry, we want to capture the concept in a way that is generalizable. And so there are different definitions. This is from a dictionary. A dictionary says that a robot is a machine that resembles a living creature in being capable of moving independently and performing complex actions. Oh, sorry, Andrea, you need to... Okay, you can go ahead.
Ok, donc définir un robot en lui-même est assez compliqué. Donc, dans le milieu, ils ont tendance à donner une définition générale de qu'est-ce qu'un robot. Et la définition du dictionnaire dit qu'un robot est une machine qui ressemble à une créature vivante, capable d'effectuer des tâches indépendamment de l'être humain qui l'a créé.
Okay, so that definition is a bit, too general. The only main thing it says that it is a machine that resembles a living creature. That doesn't really capture what the robot is, I think. So there's this other one, this other definition. This is from IEEE, if you're aware of IEEE, International Institutes for Electrical and Electronic Engineering. It's a society. And they call a robot an autonomous machine capable of sensing its environment and carrying out computation to make decisions and performing actions in the world.
Donc, la définition précédente n'est pas assez claire, ne définit pas forcément qu'est-ce qu'un robot. Alors, l'autre définition que vous pouvez voir en encadré dit qu'un robot est une machine autonome capable de sentir son environnement et d'effectuer des tâches, mais avoir des décisions et effectuer des tâches dans le monde réel.
Yeah, what's really important in this definition is you see, you can capture the things that Barnabas, you mentioned, and Sonmo, about being autonomous. It's a machine that is autonomous. And then it says it can do three things, capable of three types of things, capable of sensing its environment, capable of decision-making, okay, computation to make decision, and then also capable of acting in the real world. Those are the three main components of a robot.
Donc, dans cette définition, vous pouvez voir qu'ils ont souligné trois principes généraux d'un robot, c'est-à-dire la détection de son environnement, la capacité de prendre des décisions et d'interagir aussi avec le monde réel.
All right, and then one other, this is from Wikipedia, one other definition, also very similar. It says here that a robot is a machine, especially programmable by computer, capable of carrying out complex series of actions automatically.
Donc, la définition suivante, c'est une définition de Wikipédia qui dit qu'un robot est une machine programmable par ordinateur, capable d'effectuer une série importante de tâches complexes.
Right. So this one here is, I would say, the most complete and specific as a roboticist myself. And it is focusing on a robot being an autonomous machine that is capable of three things, like I already mentioned. Okay, so sensing, thinking, making decisions is like thinking, computing things, and acting. Okay, so sensing, thinking, and acting are the three main capabilities that makes a machine to be a robot?
Donc, les trois premiers points, c'est-à-dire la détection, la capacité de prendre des décisions et d'interagir avec le monde réel, ce sont les trois principales actions ou concepts qu'un robot est censé avoir.
All right. So now that we have maybe some idea of a robot, I searched on Google I just searched, Google images, image of a robot. And this is what I got. If you search on Google, just put robot on Google, you will get, if you just put robot on Google, you will get these images, okay? What do these images have in common? What is the common theme around all these images of robots? What is one common thing about them?
They look like human.
Yes. Yes, who said that? Who was that? I didn't see you.
Is Arnold?
Arnold, yes. Arnold, you are absolutely right. Okay, so Andrea, you can go ahead and then translate and I'll continue.
Donc, comme vous pouvez le constater, si vous faites une recherche simple de robots sur Google, vous verrez plusieurs images. Thank you. Vous verrez plusieurs images de robots. Et Arnold a répondu que le point commun entre toutes ces images, c'est qu'ils ressemblent à des humains.
Yeah, so if you go on your computer and search for robot on Google and search images, you see something very similar to this. And like you said, Arnold and Samson, it all looks like human. So when we think about, when people generally think about robot, they think about what is called humanoid robot. This type of robots are called humanoid robots. Okay, so like see, humanoid robots are coming. So a robot from the movie Terminator. Remember the movie Terminator? I don't know if anybody watched Terminator. That is the kind of, or iRobot. That's another, robot movie. These are the ideas that we have in our mind about robot, and so that's why it's very common.
Donc, le plus souvent, lorsqu'on parle de robots, les gens ont le plus souvent tendance à penser à un robot humanoïde qui ressemble à un humain. Si vous pouvez vous rappeler aussi du film Terminator, où vous verrez en quelque sorte un robot humanoïde qui est utilisé dans le film.
Yeah, but robots are much more than just humanoid robots, okay? Robots, like we already defined, is any autonomous system that can sense the environment, that can think, make decision, and plan, and then that can act in the real world. Any machine that can do that, sensing, thinking, acting, is a robot. It doesn't have to be a humanoid robot. That's an important thing to keep in mind as you explore robotics.
Donc, tous les robots ne sont pas forcément humanoïdes. Donc, un robot, de manière générale, c'est tout système autonome capable de détecter, de prendre des décisions et d'interagir avec le monde réel. C'est en quelque sorte la définition complète de ce qu'est un robot.
Okay, so I'm going to show you a bunch of robot examples. And they're all very different and all very, very exciting designs, okay? So hopefully you can see, I have a bunch of videos here.
Innovative, bold, dynamic. Since 2011, we have been pioneering mobility of the future with our manned and fully electric vertical takeoff and landing air taxis. Now, we have expanded our capabilities in the sky with an
project. The result, in 2018, we launched a utility drone project as a largely independent.
A drone which is ushering in a new era of urban and rural flight and offers unlimited potential. Progressive, efficient, and fully electric, the Volo drone is the first aircraft of its kind that brings a new standard to the third dimension of sustainable transport. The Volo drone works with different equipment, such as box, sling, sprayer, or even customized.
All right, so that is one example. It's a cargo drone, heavy duty cargo drone. You can use it for delivery of items. You can use it to even transport, heavy items and other things. So that's one example of a robot.
Donc là, vous avez des vidéos de quelques exemples de robots.
All right, and you see that robot did not have any human shape or human features. It was an entirely mechanical system, but was able to, it has sensors, it can plan, and it can also act by flying, flying around. Let me show us another one.
Donc, comme vous aurez pu le voir dans la vidéo précédente, ce robot n'avait pas forcément la forme d'un être humain ou peu importe les caractéristiques d'un être humain, mais il avait les trois capacités de sensing et interaction with the world.
So this one is maybe what you might have been hearing more about in the news. It's self-driving cars. So this is a Tesla self-driving car. You can see the car is driving on its own. There's a driver there, but the person is not holding the steering wheel, is not pressing the pedal. The car is now a robot because it has sensors that can sense the road, sense other cars, and it can plan how to drive safely. And then it also is able to move the car by controlling the wheels of the car.
Donc là, vous avez une voiture automatique qui est capable d'être contrôlée par elle-même. Et voilà.
Okay, so this is really exciting, right? When you think about robots, don't just think about some humanoid robot, but anything that has intelligence and can sense, think, and act really is a robot. Okay. Let's see another example. So these are industrial robots that is usually applied in automotive industry. These robots are actually building different components of a vehicle. Okay, the robots have sensors to know where they need to move to. They can pick up objects, they can place objects. And this way you can have a fully autonomous assembly line for a car.
Donc ici, vous avez un robot industriel pour des véhicules. Donc, il peut soulever des objets, les placer. De cette manière, vous avez une chaîne automatique de production de véhicules.
Yeah, so you can see how exciting this is, right? You can have this type of robot that can fully automate a manufacturing line. Okay, I'm going to show us maybe one or two more for the interest of time.
Due to increasing risk of COVID-19 virus in the world, it's getting harder to find fruit pickers, which results in the severe shortage of workers available to pick fruit at orchards. So if there is a solution to this, of farmers have to suffer from unemployment due to rising costs and low labor cost. Having an answer to this, Tival Aerobatics Technology find a technological solution by developing a flying fruit harvesting drones, flying fruit pickers, and autonomous robots, FAR. Each of its units consists of a wheeled-based vehicle, which travels up and down the rows of fruit trees and acts as their power source. The robot picks only ripe fruit by classifying its size and ripeness. After choosing the fruit, the robot works out the best way to reach it, and its picking arm helps it to grasp the fruit. It can be said to be a 21st century way to pick fruit using Tival's harvesting management application. We need to provide some necessary detail.
All right, so that is very exciting, right? You can see this drones are used to harvest fruit from the trees from an orchard. Instead of having people struggle to reach very high in the tree, use a ladder, you can actually use drones to perform this. So this is really interesting application of drones in agriculture.
Donc, comme vous pouvez le voir, il y a des drones qui récoltent des fruits. Donc, au lieu d'avoir des personnes qui se débattent chaque jour pour atteindre des arbres vraiment très hauts pour récolter des fruits, vous avez des drones qui sont capables de le faire. Donc, c'est très important pour le domaine agriculture aussi.
Let me show us one more here, because this is agricultural focused. This is a robot that can be used for weeding.
Donc la dernière vidéo, c'est un robot qui aide au désherbage des champs.
Where you can scan and detect weeds. This is one of the tasks that you have in this competition, is to do weed detection. So similar to what you can see this robot, agricultural robot doing, using his camera to detect weeds on the ground.
Donc ça, c'est en quelque sorte un peu comme le challenge que vous avez cette année, c'est-à-dire détecter les mauvaises herbes et...
Okay, and then also moving around the crop rows is also an important thing that will have you to do in this competition as well. These are important applications for agricultural robotics. Okay.
La détection de culture aussi pourra être un bon atout pour l'agriculture robotique.
All right, so I wanted to show us this different videos just to get you excited about what you can do with robotics. Robotics can be applied in so many directions, in so many industries. Africa is growing in this area of robotics. And so we need people like you who have the passion and interest to build your skills and competency so that you can actually be a strong labor force to drive robotics application in Africa and around the world. Okay, we need to have more talented engineers who can build and design and program robots to solve industrial challenges and, you know, in all these different applications.
Donc, l'industrie robotique en Afrique est en pleine croissance. Donc, on aura besoin de personnes comme vous, motivées et intelligentes pour développer l'application de la robotique dans tous les domaines industriels du continent.
Okay, so if you're not excited about robotics, I want you to be excited about robotics because it is the future. definitely. And there's just so many areas of application. Okay, but let's move on. Let's move on.
Bold,
Oh,
dynamic.
sorry.
Since 2011, we have been pioneering mobility.
Okay, sorry. It is trying to play them, unfortunately. But I want to move on.
Due to increasing risk of COVID-19 virus in the world.
So I will share the slides with you, also you can watch the videos later. Unfortunately, it's trying to play everything before I can move on to the next slide.
Donc, le document PowerPoint qui vous est présenté vous sera transféré comme le précédent dans le site.
Okay, all right. So just one more video I want to show you. This is of a small and growing company from Ghana that is trying to explore agricultural robotics. And there's a nice video that they have of some of their prototype system. And this company is also going to be attending the the panel. One of the chief engineers in the company will be there to talk about the experience. So I encourage you to be there for the agricultural robotics panel in May.
Donc, dans cette vidéo, vous verrez, c'est une vidéo de motivation par rapport à l'agriculture, de la robotique agricole en Afrique. Donc, c'est une compagnie ghanéenne qui a un prototype qui permet de faire plusieurs applications par rapport à l'agriculture. Et ils viendront discuter avec vous en mai. Donc, voilà.
All right, so that's very exciting. It's a young company that is starting out in agricultural robotics in Ghana. All right, so those are just some examples of robots. But really, like I said, all robots do these three main things. They are sensing, they are thinking or planning, and they are acting, okay? Those three things is what they do.
Donc ça, ce sont les trois principales actions, les trois principales fonctions d'un robot, c'est-à-dire de détecter, de penser et d'agir.
All right, and so this is the most fundamental architecture for a robot. The robot will use sensors to understand the environment, the world, using its sensors, the different types of sensors you can imagine. The sensor information will be processed in the planning, and then the result of the planning will go into some kind of actuator, or mostly an actuator that will impact the world or the environment. And that is the continuous loop of sense, think, and act. Hello, Andrea.
Can you summarize?
Okay.
What you just said?
So sensing, thinking, and acting are the three main components. You use sensors to sense, the different types of sensors. The thinking will process information, and then the actuators will act on the decision.
Donc, l'architecture fondamentale d'un robot, c'est la détection, pensée. Donc, à partir de pensée, il va procéder, c'est-à-dire filtrer toutes les informations afin de de faire une application directe dans le monde réel.
All right. I will just move on from there. So the other core, under these core components, you can see how electrical engineering, software engineering, and mechanical engineering are all part of what makes up robotics.
Alors, comme vous pouvez voir, les trois filières électriques, informatique et mécanique sont en quelque sorte les trois séries qui forment la robotique.
Okay, so any real robot system will need some electrical component and some mechanical structure and definitely some software system for it to be able to perform its tasks.
Donc, tout système robotique aura forcément besoin de sa partie électrique, une structure mécanique et de sa partie logicielle pour effectuer une tâche.
Okay, and okay, before I move on, actually, and so maybe just some comment here, you know, if some of you are from the mechanical background, that is a very important part of robotics. Some of you are from an electrical background, that is also very important. Some of you are from software or computer science. They're all very important parts of robotics.
Donc, juste pour vous dire que les filières électriques, mécaniques et informatiques sont des filières vraiment importantes dans la robotique.
Yeah, now because this competition is mostly virtual this year, we are focusing a bit more on the software side, but next year and in the future, we will see how we can include both mechanical design and fabrication and also electrical prototyping.
Donc, vu que la compétition de cette année est virtuelle, on va plus se concentrer sur la partie software, c'est-à-dire logiciel. Et dans les années qui suivront, nous pourrons peut-être faire pour la partie électrique et mécanique.
All right. So before I move on, is there any question in this moment?
Est-ce que vous avez des questions?
Okay. I know I received a request for recording from Kennedy. Kennedy, we are recording and we will upload the recording to the website and we'll share the link with you, with everybody. So don't worry about recording on your end. Other thing I also want to mention is to remind the people who had issues with setting up their PC. So far, we only have five. We only had 5 people put comment in the chat. I know we had at least 9 people who reported that they don't have their PC set up. So please, I just want to remind you that this is very important. So please, please go back on the chat and post your name, your team name, and what is the challenge you're facing so we can follow up with you.
Donc, la réunion présente sera enregistrée et postée dans le site. Et aussi pour toutes les personnes qui ont toujours des problèmes sur la configuration de leur ordinateur, vous devez écrire dans le chat le nom de votre équipe, votre nom et le problème que vous rencontrez. Et nous vous répondrons sur Slack.
Thank you. Anybody have any questions before we move on to this next part of the workshop?
Est-ce que vous avez des questions?
All right, so we'll move on. I want to now show us the, this is the PARC agriculture robot. Okay, this is what you'll be using. If you already started, this is what you have in the simulation.
Donc, ça, c'est le système de PARC, c'est le robot pour la compétition.
Okay, and I want to walk us through what are the different sensors. Okay, so we have a number of sensors. The first sensor we have is a 2D laser scanner.
Donc, nous allons un peu parler des capteurs qu'il y a sur le robot. Donc, le premier capteur, c'est un capteur laser.
Okay, this 2D laser scanner sends out laser rays in a from this point here, as you can also think about like this, sends out laser rays in all directions, 360 degrees. And based on where the ray is reflected, you can tell the distance to that object.
Donc, comme vous pouvez le voir, le laser peut réfléchir sur plusieurs surfaces et en fonction de la distance qu'il y a entre l'objet et le laser, le robot sera capable de déterminer.
Okay, this sensor is usually very good for mapping your environment.
Donc, ce robot est naturellement vraiment bien pour la cartographie d'un environnement.
Okay, and also for sensing obstacles. If you have obstacles around, like you see this obstacle here or the wall, you can use this sensor to tell the robot, oh, there's an obstacle here, there's a wall around, something like that. This is a good sensor for that.
Donc, ce capteur aussi, c'est bon pour détecter les obstacles.
All right. So that is one of the fundamental sensors that you use for a mobile robot. The mobile robot would usually have a 2D laser scanner.
Donc, ça, c'est un élément essentiel que vous aurez sur le robot.
All right, the other one that is very common is a camera. On the PARC robot, we have 3 cameras, okay? We have one camera here facing forward, and then we have 2 cameras here and oh, sorry, the camera is here, this one, the Z camera. We have one camera here, and we have 2 cameras here, one here and one here. And these are the camera views.
Donc,
we have 3 cameras.
sur ce robot, vous avez 3 caméras.
Okay, 3 cameras, one facing forward and 2 facing down. These 2 cameras facing down is what we'll use for the weed detection. So this is the view of the camera facing down. You can see that it is capturing the crops on the ground.
Donc, vous avez 3 caméras. La première caméra, c'est celle qui est vers l'avant. Et les 2 autres qui sont sur les côtés sont, comment dirais-je, capturent en fait pour la détection des mauvaises herbes. Donc, elles regardent vers le bas.
Okay. And the third sensor that we have on the robot is a GPS. GPS means Global Positioning System. Okay, GPS uses satellites in orbit to track the position of things using a receiver. Okay, so to summarize that, we have one GPS receiver in the robot, and with that we can collect GPS information, location information from satellites.
Donc, comme troisième capteur, vous avez un GPS. Et ce GPS sera relié à des satellites qui vous donnera la position exacte du robot.
Yeah. Okay. Any questions about the PARC agricultural robot system and the sensors that we have?
Est-ce que vous avez des questions par rapport au robot?
Yes, I have a question, please.
Oh, yes, go ahead.
Yeah, I would like you to kindly explain the function of the GPS sensor again? Thank you.
Okay, the function, you mean the function as in how you will use it in the competition? Is that what you mean? Or how it works?
Basically how it works.
Ah, okay, okay. All right, how the GPS works. Okay, so at the very high level, how the GPS works is by a concept of triangulation, okay? That you have multiple satellites, you have multiple satellites in orbit, and all those satellites are sending messages to your receiver. Your receiver can capture those satellites. A similar way to how your phone captures GPS signal, okay? Now, these satellites are sending these messages to your GPS receiver. Andrea, you can go ahead.
Donc, un GPS, elle demandait c'était comment est-ce que ça marche un GPS. Donc, il a dit qu'un GPS fonctionne par un système de triangulation, c'est-à-dire que les satellites vont envoyer des messages à votre récepteur et ce récepteur va transmettre l'information.
Okay, so the receiver is receiving messages from the satellites, and the satellites are sending a message about their location to the receiver. Okay, and so if you have multiple messages about location of the and the time, the distance to travel, and information about this different satellites, if you have more than two, if you have two or more, you can actually calculate the rough estimates of where the receiver is. Okay, so you get information from one satellite, information from another satellite, and based on those information, you can triangulate and calculate, okay, this is where the receiver should be based on the time I received the information from the different satellites. And so it's using information from multiple sources in space to hone down on which position in space the object that is receiving is. And there are other ways that you can improve these estimates, but fundamentally, this is the idea.
Donc, dépendamment du nombre de satellites que vous avez, vous aurez approximativement la position exacte de votre récepteur sur la Terre.
Okay, so hopefully that was kind of a helpful description. In the simulation, we don't have a real satellite, but we can simulate this function, and the result would be getting longitude and latitude information. Okay, so GPS position information is usually in longitude and latitude. Remember, maybe if you took some geometry class, we talk about longitude and latitude. So that is how the GPS information is encoded as longitude, latitude, and maybe also altitude of the receiver. Okay.
Donc, un GPS fonctionne avec la longitude et la latitude de l'endroit spécifiquement. Et en fonction de ça, pour la phase de simulation, nous allons utiliser la longitude et la latitude.
All right. I think somebody else had a question. Somebody else was trying to ask before Jamaica. Yes.
Yeah, I have a question. I wanted to ask, is your laser working well? Because this side, when we try to when we're trying to subscribe to the laser scanner, right? The laser scanner topic,
Yes.
Our robot started to just freeze. Like the real-time factor, it will be 1 constantly when you're not subscribing to the laser. And then when you, the moment that you try to subscribe to the laser, it goes down to 0 and it just freezes. So I wanted to know, is your laser scanner working well, or it's the issue with our computers this side?
No, that's a very good question. That's actually a very important question. That has been a major issue that we have been trying to solve. There have been some conversation about this in the chat. Not in the chat, in Slack. We have a solution to that problem that we pushed to GitHub today. So after this workshop, I will comment in the Slack to update everybody about what we have changed to make it to work now. Okay. All right. So we have a solution to that problem. We also noticed that same problem. We have pushed the updates to GitHub so you can easily pull it. But once we finish this workshop today, I will give an update on Slack so that everybody can know what we have done and how they can continue to use the current system. Okay. All right, any other question? We can move on. All right, so we'll move on. All right, so now we have some idea of different sensors. I want us to do a simple example of doing robot control using ROS. Andrea, are you there?
Can you repeat?
I said that, so I would like us to start with an example of robot control using ROS.
Donc, on va faire un petit exemple de comment contrôler un robot avec ROS.
All right, and this is the example. The example is a very simple example that I just made as an introduction, especially for those who are new to robotics or using ROS. And the example is approach barn task. Okay.
Donc, cet exemple, c'est approach barn task, donc c'est-à-dire s'approcher de l'étable.
Okay, and the idea is pretty simple. The robot starts somewhere in the farm. See, this is the farm. The robot starts somewhere in the farm, facing the barn. This is the barn. And the task is for the robot to drive towards the barn, approach the barn, but stop once it is 6 meters away from the barn. Okay, that is the task. The simple task of letting the robot drive up to the barn and stop once it is 6 meters away from the barn.
Donc, la tâche, c'est de faire en sorte que le robot parte d'un point A à un point B et s'arrête à 6 mètres avant l'étable.
Okay, so this is in Gazebo. This view here is in Gazebo, and this view here is in RViz. Okay, so RViz is what we use to visualize sensor information, and this is what we use to visualize our simulation. Okay, so Gazebo is used to visualize simulation. RViz is used to visualize sensor information.
Donc, l'image de droite, c'est gazebo, ça vous permet de simuler, en fait, faire des simulations par rapport à la tâche. Et l'image de gauche, c'est... I don't remember the name of it.
Arviz.
What's the name?
Arviz.
Et ça vous permet ça permet de visualiser les informations à partir des capteurs.
All right, so let me see what I have. Okay, all right. So I want to get some input from you. How would you solve this problem? Okay, so the problem is robot starts here. Okay, I want you to move until you reach 6 meters from the barn and then stop. How would you solve this problem? Thinking about sensing, thinking, and acting as how your robot will operate.
Comment pensez-vous que vous pourrez résoudre ce problème, c'est-à-dire d'approcher la ferme et de s'arrêter à 6 mètres avant d'atteindre l'étable?
Wait, what? Caption is in Spanish? What does that mean? I didn't set caption. Andrea, I don't know how to fix that. Okay, I'm waiting. Does anybody want to share some idea? How will you, what are some things you can do to make the robot move and achieve the task? The task is to drive from a start location up to 6 meters away from the barn and stop. How do you program the robot to do this?
All right, let me give it a try.
Yes, please.
Although in what though?
Yes,
in what?
yes.
First of all, I might use computer vision for identifying which barn I'm approaching. Then I'll also, once I identify it, maybe from the algorithms, I can track it, the position. Then from using sensors such as the laser sensor, LiDAR sensor that reflects distance, I can tell when my data is 6 meters away, and I will give the robot a command to stop. So
yes, Samson, that is a wonderful, that's very, very, very correct. I mean, the thing about robotics is that there's always many ways to solve any problem. Okay, there's always many ways to solve a single problem. But what you have said is a really good way to solve the problem. So that's very good. Does anybody have a different idea or similar idea, but you want to share?
Est-ce que quelqu'un d'autre aura une autre réponse?
Can I try?
Yes, please go ahead.
Okay, so iterating what Samson said, also I think we can also use sensing per se to check after setting basic parameters like the positioning of the robots and the position, so the XY plane, to see which direction is going to move in to get to the barn within that 6 meter range. I think also to check with the use of sensors to check whether there's an obstruction while moving to that 6 meter distance towards the barn. Because if there's an obstruction and you haven't identified whether you can pass through it or move around the obstruction, it might affect the tax.
Yes,
so
yes.
I think sensing.
Yeah, so that's a very good point, Christian. Thank you for sharing that perspective. So to summarize what Christian said, using sensing to be able to know where you should move to, but also use sensing to detect any obstacles that you need to avoid while you're moving towards the barn.
Donc, il disait qu'utiliser la détection va nous permettre d'éviter l'obstacle et de savoir où est-ce que se trouve la ferme par rapport au robot.
All right, very good. So let's see what we have. So very similar to what was said by our two wonderful robotics guys here. Just to describe some ideas about how you can use ROS. For the sensing, I've only limited this to using the 2D LiDAR to sense the distance of the barn, okay? The barn is in front of you, but it is some distance in front of you. You want that distance to become 6 meters and then stop, where you don't know the distance. So you use the sensor, the 2D LiDAR, to get the distance of the barn from the robot. Okay, so maybe I summarize that you can use the 2D LiDAR sensor to sense the distance of the barn from the robot.
Can you
Sorry, do you want me to repeat
you hear me?
that? Would you like me to repeat that?
Yes, can you repeat?
Right, so you can use the 2D LiDAR that we already talked about to sense the distance, or to measure the distance from the robot to the barn, okay?
Ça nous permet de mesurer la distance du robot à l'étable.
Okay, and once you have that distance value, you can have some code that is in your thinking or planning to determine what you can determine. Am I up to 6 meters or not?
Donc, en fonction des données que vous aurez du 2D LiDAR sensor, vous serez capable d'établir un code qui vous dira précisément si vous êtes à 6 mètres ou pas.
Okay, and then based on that, you can send some command to your motors, that's in the act area, to say move or stop, or move fast, move slow, or stop. You know, different things you can tell the motors to do based on what you have planned.
Donc, dépendamment de ce que vous avez écrit dans votre code, vous serez capable de donner une instruction à votre robot, c'est-à-dire de bouger ou de ne pas bouger.
All right, so this is a very basic and simple architecture for a simple robot task. You can see here we're only using one sensor and only one set of actuator. Okay, only one sensor, one actuator, so it is simple robot system.
Donc, comme vous pouvez le voir, je n'utilise qu'un seul capteur. Et en fonction de ce seul capteur, j'ai pu établir en quelque sorte les codes et les actions que doit effectuer le robot.
All right. And like we also talked about, I think when maybe Samson mentioned that you can use a camera. Okay, so if you use a camera, you can add a camera as another sensor to capture more information that you can then use to think or plan that will help you to know better how to complete your task.
Donc, vous pouvez bien évidemment utiliser aussi une caméra qui vous permettra d'effectuer vos tâches un peu plus facilement.
But in this case, our task is very simple. We just want to drive up straight until we reach 6 meters from the barn. And once we get there, we want to stop. So a 2D LiDAR is enough for us. Okay. Looks like we might have lost Andrea. So a 2D LiDAR will be enough for us in this case. And what is then important is how we can write some simple code to process the sensor information so that we can control our actuators effectively. All right, so please bear with us. I think Andrea is dropped off. Hopefully she can join back very shortly. Just some very brief overview about how ROS communication works. This is an important part that you need to study. We have tutorials on the website that gives you nice videos that you can use to learn about how ROS communication works. Okay, we follow what is called a messaging protocol. Okay, where your messages will be flowing through what is called topics. Okay, so topics are the message definitions, and you can use messages to communicate between different nodes of your system. Okay, so this, if you're new to ROS, this might all be sounding very complicated. It's not complicated at all. The concept is simple, but maybe you need to be familiar with it. Fundamentally, what it means is that if your camera has some, maybe let's say now in this case, if your LiDAR 2D scanner has some data that it is processing, it is collecting, and you need that data, you need to subscribe to the topic that data is being published on. Okay, and so you will be a subscriber. You subscribe to that topic, and you can receive messages from the LiDAR sensor. Okay, and if you also want to send commands to an actuator, like the wheels of the robot, will be a subscriber or a topic that you can publish to, and so your code will be a publisher. Okay, so there's a lot of detail that needs to go into ROS introduction. We have put some good videos on the website. So please go through those videos. If you have any challenges with the videos, you can always come on Slack and we can provide some later information to support. But mostly, if you watch those videos and go through the tutorials online, you should be able to get a good grasp of ROS. Okay. All right, it looks like we have Andrea back. So Andrea, are you able to can you hear us and can you speak? Hello? Hello, Andrea?
Hello, can you hear me?
Yes, yes. Okay, are you able to speak?
Yes, I can.
All right, so I think what might be helpful for you to translate here is that we have very good resources on the website to do an introduction to ROS. that we want everybody to go through. If you're new to ROS, please go through those resources on the website. And if you have any challenges, you can always come on Slack and we can discuss those challenges.
Et donc, nous avons des ressources assez exhaustives dans le forum qui pourront vous permettre de manipuler facilement ROS. Donc, mais si vous avez des difficultés par rapport à cela, vous pouvez toujours venir dans le Slack et on vous donnera des explications un peu plus poussées par rapport à cela.
All right, thank you. So I want to actually get us to where we can, I actually planned for us to write some code this afternoon. So I want us to maybe get there, but my plan is for us to be done in about 30 minutes, okay?
Donc, d'ici 30 minutes, normalement, nous devrons avoir fini.
Okay, so just to give some high-level idea, in this system of the approaching the bound task, we will subscribe to the LiDAR topic called scan, and that scan will have messages that we can use to get data about the LiDAR information. Okay, that's the first part. So we will be subscribing from the LiDAR topic to get scan data.
Donc, pour cette tâche de s'approcher de l'étape, vous aurez besoin des données, de follow le leader topic pour ensuite avoir les données relatives au leader topic.
Okay. And in the think or plan area, we will write some code, some simple code for us to think about how to process the sensor data and how to use that to make some decision on how to move.
Et ensuite, dans l'espace de think and plan, vous devrez écrire aussi un code qui vous permettra d'évoluer dans le leader topic.
Okay, and then once we have our thing to think and plan, we will publish this to the command velocity topic, which is what will be used to control the robot's motion. Okay, hello?
Du leader.
Oh, hello, Andrea. Did you?
Yes, I can hear you. It's okay.
Can you repeat that?
Donc, je disais que par rapport à la partie de acte, vous allez devoir publier les topics, c'est-à-dire les informations qui vous seront données par rapport au leader sur la partie acte.
All right. Oh, actually, it should be other way around. But so this happens continuously in a loop. Okay, actually the loop should be opposite, not this way, should be opposite, but it happens in a loop that has a control frequency. Control frequency just means how quickly do we loop through this process. Okay, so how many times in a second are we looping through this process? That is what control frequency is. Hello, Andrea, are you there? Hello, Andrea?
She's muted.
Can you hear me?
Yeah, are you having issues with your audio or internet? What is the problem?
The connection is, I don't know what's happening.
Ah, okay, you have some connection issues. Can you hear us now? Okay. I guess you might need a moment to get resettled. All right, so the next thing I really want to do is to do some live coding. Okay, so we can actually run the task, and I can walk you through a simple example of how to implement this in Python using Gazebo and ROS. Okay, that is what I want to do for the next maybe 20 minutes of this this workshop. Okay, now before we do that, does anybody have any questions? Yeah, I know. Did you send me, did you ask it? Did you have a question? Did anybody have any question? We've covered some amount of content. I would like to pause for a minute to. Oh, okay. Yeah, I know. Please, yes. If you can help with translation, that would be wonderful. As we wait for Andrea to get back on. Please, yes. So please, any questions? Anybody has any questions?
Est-ce que quelqu'un a des questions, s'il vous plaît? Vous avez des questions, s'il vous plaît?
Bonsoir. Est-ce qu'après, il pourra nous partager le PDF, le PowerPoint?
Okay, the question is, after this session, will be available for us.
Yeah, you mean the PowerPoint? Yes, yes. So after the session, we will provide the video, that's the recording, video recording, and also the excuse me, and also the PowerPoint, so that you can review on your own time.
So
Can you hear me?
All right.
Can I go?
Hello?
Yes.
Can I go? Après la section, il sera mis à votre disposition la vidéo qui est en train d'être enregistrée ainsi que le PowerPoint. Merci.
All right, thank you, Arnold. Andrea, is your internet stable now?
Yes, I think.
All right. So I guess you can take over. Thank you very much, Arnold. I really appreciate your support. All right. So if there's no other questions, let us jump right in. How I want this to be done, or how I plan to do this, is I will actually share my screen, and I will open up my Gazebo and my VS Code, where I will write the code. Okay. If you want to follow along, I will put I can also share that with you. Okay.
Donc, il va partager son écran et il va ouvrir en fait la section de code, c'est-à-dire l'application VS Code, pour pouvoir le faire en même temps que vous. Donc, si vous pouvez le faire en même temps que lui, ça serait bien.
All right. So the code that we are going to be using for this brief part is on GitHub. Okay, so I'm showing you, this is the PARC Robotics GitHub page. It is this one, Intro to Robotics Workshops. Okay, so if you click that, I'll put this link in the chat so that if you want, you can follow either now or later. You can always check. But let me put this in the chat right away so you have access to it, everybody.
Donc, le code qu'il va faire maintenant est disponible dans le GitHub de PARC. Et après la réunion, sentez-vous libre d'aller et de refaire en fonction de ce que vous trouverez sur le GitHub.
All right. So I have instructions there on how you can use this. But basically, I already have it set up. So I will show us I will show us what we have so far.
Donc là, il vous montre un peu les updates.
Okay, so what I'm going to be running is this command here. Ross launch intro to robotics workshops example1.launch. Okay, that is what I have. And that should launch the gazebo environment and RViz also.
Donc, il a lancé la commande qui est sur la section Run et ça a ouvert Gazebo et Rus.
Okay, make sure you can all see my screen. All right, very good. All right, so like I told you, like we showed you, this is the farm. This is the barn here. Okay, so this is the barn. This is the robot. And the goal is for the robot to move up straight until 6 meters away from the 6 meters away from the barn. Okay, once it's 6 meters away from the barn, it should stop. Okay.
Donc la tâche, c'est que le robot aille s'approche de l'étable et qu'il s'arrête à 6 mètres avant d'atteindre l'étable.
All right. I will open RViz. With RViz, like I mentioned also, RViz allows us to visualize, RViz allows us to visualize sensor information. Okay. Let me see.
Donc là, il a ouvert RViz et RViz vous permet de visualiser les informations qui sont retransmises par les capteurs.
All right. So hopefully you can see my screen. Can everybody see what I'm showing here? Andrea, is it visible to you?
Yes, it's visible.
All right. So if you're new to RViz, you know, some practice can help you to get more used to different things. But this is actually, there are different sensor views here. This view here, image view, is the view of the camera facing forward. Okay, so this is the camera view. You can see the barn is in front here. Okay, and the trees here. So this is the forward facing view.
Donc, comme vous pouvez voir sur l'image, vous avez les tables et l'arbre.
Okay, and this large view is actually, this projection here is from this is the point cloud or the depth image that we can get from the camera. And the red dots are the different laser points from the laser scanner. Okay, so these are the laser points from the laser scanner. And that is the main things. Okay, let me summarize that for you, Andrea. Wait, are you still there, Andrea?
Yes, I'm still there.
Okay. If you need me to summarize, you can just ask right away so that I can do that. So on this view, you have these red points are the laser scan points from the laser scanner. And this projection here is from the depth image. So these are the laser scan points, the red ones, and this is a projection from the depth image of the camera.
Donc, les points rouges que vous pouvez voir alignés sur les tables, ce sont les points des lasers. Et les petites projections bleues que vous pouvez voir sur le sol et sur les tables, c'est en quelque sorte des projections de profondeur faites par le capteur aussi.
Okay, all right. So this is generally how you would process your information, right? When you have a new task, you will come to RViz and you will try to visualize your sensor information to get some idea of what the system looks like. Okay, so visualization, you will use RViz to do visualization to get what, to get an idea of what your system looks like, what your sensors can see.
Donc, vous pouvez utiliser RViz pour visualiser en quelque sorte à quoi votre système ressemble.
All right, so that is good. Now, I actually want to get into writing the code. Okay, so we will come over here and we will try to write code together.
Donc, à présent, vous allez entrer dans la phase d'écriture du code.
Okay, I don't really expect you to do this with me, like on your own computer at the moment. But if you can pay attention and if you have any questions, you can ask questions. That would be good, okay?
Donc, vous n'êtes pas obligé de le faire en même temps que lui maintenant, mais si vous avez des questions par rapport à ce qu'il est en train de faire, vous pouvez toujours les poser.
So, sorry, I have a question.
Yes.
So, currently, the code you're typing, do you have it on GitHub, or I'm supposed to look at the video after to get the code?
Oh, the code is, wait, sorry, what is this? So my computer is a bit slow now because, okay. The code I will put on GitHub. I will put that on GitHub after this, but I want, instead of having you to just read the code on GitHub, I want to walk through it with you here as well, okay? And so at least
yeah,
you can
I don't mind that.
Yes, yeah, you can get some conceptual idea on how to go about writing the code. Okay, so that's the main idea for this session. Okay,
yeah, thank you.
A little bit behind, but see what we can do. The first thing that we do is okay, so there's some Python, you know, there's an assumption that maybe most of us are familiar with using Python. Okay, so I'm using Python for this. You know, if you have experience in C++, you can use C++. If you have experience with MATLAB, you can also use MATLAB. But for this, I'm using Python.
Donc, le code sera disponible sur la plateforme GitHub. Et pour ceux qui ont l'habitude de coder, vous pouvez voir qu'il y aura des caractéristiques de Python, de MATLAB et plein d'autres langages de programmation. Donc, il va essayer d'écrire le code devant vous pour que vous puissiez avoir une vision en quelque sorte de comment est-ce qu'on écrit le code. Mais le code sera disponible sur GitHub.
All right, so I'm just setting up some basic things that are maybe more of Python issue than robotics or this is just basically how you set up a Python file to run. Okay, so I'm going to, this is called the shebang. And then this is just setting up my main function. Okay, so my main function is where I will now be writing the code. Okay, all right, so there's some basic things about Python that I'm going to assume that you know. It's okay, you can ask me if you have questions about those things, but I'm not going to spend too much time explaining some Python basic things. We'll focus more on the robotics part.
Donc, si vous avez des questions pendant qu'il écrit le code, vous pouvez toujours ouvrir votre micro ou l'écrire dans le chat.
Okay. So the first thing that we will probably have to do if you're ever writing code is that you have to import the different libraries or packages that you need. So we are working with ROS and Python, so we'll import ROS-Py.
Donc, pour pouvoir commencer à écrire votre code, vous devez importer les bibliothèques nécessaires à l'écriture du code. Donc, il a importé la bibliothèque ROS-Py.
Okay, and then now we want to define our function, right? So we want to define the main function that will run whenever we run the script.
Donc maintenant, il va définir la fonction principale pour écrire le code.
All right. The first thing that we do for ROS is to initialize the ROS node. Okay. So we initialize a ROS node.
Donc la première chose qu'il va faire, c'est initialiser le nœud ROS.
This is how you do it using this structure. You can give it a name. I'll give it this name. Okay. And I think that's mostly it. All right, so I give it this name, initialize the ROS node.
Donc, il vient de donner un nom à l'initialisation de la ROS node.
All right, the next thing that we want to do, remember we talked about a loop, control loop, sensing, thinking, and acting. Okay, so we will create a loop. How do you create a loop in Python?
Donc, si vous vous rappelez, lors de l'introduction à la robotique, il avait parlé de la loupe générale d'un robot, c'est-à-dire le sensing, le think and act. Donc, comment pensez-vous qu'on peut établir un loop par rapport à ce qui est devant vous? En Python, comment est-ce que vous établissez une loop en utilisant le langage Python?
Okay, does anybody want to remind us how to create a loop? A loop in Python?
You can either use a for loop or a while loop.
Right, thank you. So we'll use the while loop. And we would say loop until ROS is shut down. Okay, so this is how we set it up. So looping until ROS is shut down. Okay, so while ROS is not shut down, keep looping.
Donc, il a établi la loupe, la boucle, en fonction de la librairie ROS-Py, c'est shutdown.
Okay, all right. Now I'm just laying out the structure. This is very simple, basic structure. I think it's good as a fundamental strategy. Basic structure is that in the loop, you will sense first, then you will think, come up with what you want to do, then you will make the command of what you want to do. Okay, so very simple structure. I think it's very important. as a fundamental approach. Okay. Andrea, do you need me to repeat that? If you need me to repeat, I'd like you to tell me so I can repeat.
Yes, can you repeat it?
Yeah, if you need me to repeat, just tell me, right? Don't just wait. All right, so I set up the control loop. There are 3 main steps: to sense, think, and act, the same way that we showed in the slides, right? So sensing, collecting sensor information, processing that in thinking, and then using the result of thinking to act. And we'll just put that here in the control loop.
Donc, dans la boucle contrôle, il a configuré 3 options, c'est-à-dire le sensing, le think and act.
Okay, thank you. Some other thing that we need to do is to set the control frequency, okay? We need to set the control frequency.
Donc, ensuite, vous allez configurer la fréquence, les fréquences de contrôle.
All right. By the way, if anybody, if you have a question, feel free to stop us to ask. Okay. Very happy to answer them. Okay, so this.
I just want to.
Yeah, go ahead.
Hello?
Go ahead. Go ahead.
I just want to confirm on ROS init node. I just want to ask on ROSPy init node. The approach ban example is just like a random name that you can just put.
Yes, yes. Very random name. Okay, you can give it any name. It's just a string. You can give it any name. You can put whatever you like. All right. All right, so I want to set the frequency. Let us say I put 1. 1 means 1 hertz. Okay. Hertz means
Donc, comme vous pouvez voir,
number of times per second, right? Frequency is number of times per second. So 1 hertz would be 1 time per second.
donc, comme vous pouvez voir, il a établi HZ, c'est-à-dire Hertz, c'est-à-dire une fois chaque seconde.
Okay, and then also I think I want to also track the time. So that'll be easy for us to see. So for time, I will import a time package.
Donc, il a ajouté le temps dans le setup, dans la configuration. Du coup, il a ajouté une bibliothèque relative au temps pour pouvoir configurer le temps.
I will save the time at the beginning as t start. Okay, that is the time. Okay. I think now I have what I need. I can go inside the loop and I can set sleep. So sleep would tell the loop to pause for this time that I've set. So 1 hertz. So it means that the loop will pause for 1 second and then go back to looping. Okay. So I'll repeat that. The loop, the loop will do sensing, whatever I put under here, whatever I put under here, whatever I put under here. When it gets here, it will wait for the amount of time I have set it to wait up here. Here I put 1 second, or actually 1 hertz, which is equal to 1 second. So then it will wait for 1 hertz, or 1 second. That means sleep. And then after that, it will loop back up and continue.
Donc, la fonction qu'il vient d'écrire dans la boucle Setup Control Loop, va respecter en fait le temps qu'il a précédemment écrit dans le set control frequency and time. Donc rate that sleep, c'est-à-dire la dernière ligne qui a été écrite va contrôler en quelque sorte le temps qui a été précédemment défini.
All right, thank you. And then also I am putting I want to keep track of the time since we started. So that is called time elapsed. So I will put time elapsed as well. Okay, that will help me to keep track of the time.
Donc, la dernière fonction qu'il vient d'ajouter, c'est en quelque sorte pour avoir une idée du temps qu'il reste par rapport à la tâche qui doit être effectuée.
Then it's always good to print out something so you can see. So I will print out the time. Now I'll just say processing. Okay, so I just using this print function to print out the time elapsed. And here I'm just saying, okay, I only want to have maybe about 3 decimal places and print out this statement. That is what this is doing, just printing out the statement.
Donc, il vient de mettre une commande qui vous permettra de, c'est-à-dire à partir de print, la commande vous permettra de voir en quelque sorte le temps, comment dirais-je, la fourchette de temps qu'il vous reste avant que votre tâche ne soit effectuée. Donc, c'est vous qui le décidez.
All right, so this is ready for us to test. Let us see what we can get. I will come to our terminal. Oh, I've been running Gazebo since. All right, so I will come to terminal. I'm in my terminal. Usually what you need to do with your terminal when you have a new Python script, for every new Python script, you need to make it executable, okay? Make every Python script executable.
Donc, il a ouvert le terminal. Et pour tous les codes Python, vous devez le mettre de manière à ce qu'il soit lisible.
All right, so I mean, all of this is on our website. Like this command that you should use is on the website. So, but you just need to run that on the file that you're working on. Okay. And then we can run. Okay, so we do run intro. That is where we are, and then example. .py. Okay,
donc
so
vous pouvez le mettre dans le document que vous voulez.
Let's see what we get. Maybe we don't have, hopefully we don't have an error. Okay, so we see it is printing every 1 second. You see, this is seconds. Every 1 second, it is printing processing.
Donc, toutes les 1 seconde, comme vous pouvez le voir, ça écrit processing.
Now we're showing processing because that's what we said. Oh, sorry.
Et si vous vous rappelez de ce que vous aviez écrit dans la ligne print, c'est exactement ce qui s'affiche sur le terminal.
Right. So that's what we asked it to do. This is just the base. This is just the framework. Next thing we have to do now is to write how we will do the sense, think, and act. But for now, we have our control loop is working. We have set it to 1 second, and it is working well.
Donc, pour la boucle de contrôle, vous avez fait une configuration d'une seconde et comme vous pouvez voir dans le terminal, ça marche.
Usually 1 second, 1 hertz is too slow for your system, okay? So usually you need to use higher frequency. So we'll use 10 hertz, okay? We can use 10 hertz for this task. So if I set 10 hertz,
donc il a ajouté, il a changé le nombre de secondes d'exécution par rapport à la fréquence. Donc au lieu de 1 Hz, il a mis 10 Hz. Et vous verrez que ça va changer littéralement dans le terminal.
all right, so I changed it to 10. You see what happens? You see it's moving now at 0.1 seconds, right? So 10 hertz is 0.1 seconds. So 10 times every second, it is printing 10 times a second, okay?
Donc ça va exécuter 10 fois toutes les secondes.
All right, very good. Any questions? Anybody have any questions? Is this helpful? I was wondering maybe, if you see me writing the code directly, it might be helpful for you. But I apologize, we are over time. So far, we have not sent any command to the robot. So the robot is just where it is. It's not moving, it's not shaking, it's just there. Okay.
Donc pour le moment, vous n'avez toujours pas écrit un code qui puisse donner une commande au robot.
All right, so now the first thing is to do, now we have our structure, we need to get sensor information, right? We need to do sensing. That is the first thing, sensing.
Donc vous revenez à la première tâche, celle de la détection.
All right, so now for sensing, we talked already about using the laser scanner, okay? The LiDAR or laser scanner. So that's what we'll use.
Donc pour la phase de détection, vous allez utiliser le LiDAR scanner.
So let's say that the result of our laser scanner is something that we can call scan data.
Donc pour utiliser le scanner laser, vous allez utiliser une commande qui s'appelle scan data.
Okay, we can write a function. It's always good to put everything inside a function. Makes your code easy to read and understand. So we have a function called sensor LiDAR.
On crée une fonction qui s'appelle sensor LiDAR.
Come up here and define that function, sensor LiDAR. Okay. And what we really want to do is that we want to read a message from the laser scanner device on the scan topic.
Donc, après avoir écrit la fonction sensor LiDAR, vous repartez, vous sortez de la fonction, la fonction principale pour définir là-bas la fonction sensor LiDAR et établir toutes les commandes par rapport au sensor.
Okay. So I'm just, this is not very clean code because I don't have time to do all the doc string and everything, but that's okay. I want you to get a concept. There are different ways to read sensor data from a topic. I will use one way that is called wait for message, okay? This is probably one of the simplest ways. There are other better ways, but I will use this way.
Donc, pour récolter les données d'un capteur, il y a plusieurs façons de le faire, mais pour aujourd'hui, il va utiliser wait for message.
All right, so just to give a little bit explanation, this is the sensor, this is the message topic. This is the topic name. This is the message type. is called laser scan. All right, so that's really what it is.
Donc, vous avez un topic, c'est-à-dire un thème par rapport au scan, aux données du scan, que vous allez appeler /scan. Et ensuite, vous avez le laser scan after de la fonction wait for message.
Typing correctly. So we will import this from the correct place. We import laser scan. Now we have laser scan.
Donc, vous allez importer les bibliothèques relatives au laser et relatives au message.
Okay, all right. And we will return this from this function. So we will wait until we get one message data point from the scanner. We will save it as a scan data and we will return it from this function. That's it.
Donc, la ligne return, celle qui est en violet, va vous permettre en fait à chaque fois que vous recevrez un message, ça va reprendre la fonction encore et encore.
Okay, so we have that. That is very good. So that is, we can now use this, we can use it here. This is where we call the function, okay?
Donc, parce que vous l'avez prédéfini, maintenant, vous pourrez utiliser la fonction que vous avez écrite à détection.
Let's see if we can actually print every time step what we are getting. Okay. So we'll come back here and run the same function. Okay.
Donc, après toutes les modifications, après avoir ajouté le nouveau capteur, vous allez run le code et voir comment le terminal va réagir.
All right, so we're getting a lot of information, right? So we are printing that scan data, and this is the scan data. You see, it's a lot of information. It's a bit hard to understand, I agree. It's a lot of different information. That is what we are printing here. See, we're printing this every 10 times a second.
Donc là, le terminal vous montre à chaque 10 secondes quelles sont les données récoltées par le capteur LiDAR.
Okay, so an important thing to do is to try to understand what this message type is, what it looks like. You need to, there are different ways to understand what it is. You can search online. Let me see if I can actually quickly show us an example. So this is the laser scan. I just Googled it. This is laser scan. This is the structure of the message type. Okay, this is the structure of the message type. It has many different components. What we really care about is the range. That is the readings from each point, and maybe the angles, the angle that it is reading from, okay? Let me go back one step. Right, so remember, this is how the LiDAR works. It sends out this rays in all directions, 360 directions. And based on where it is reflected from, it will measure that range or that distance. Okay. Okay, so maybe let me repeat that. The LiDAR sensor sends out rays in all directions, 360 directions, and based on where that laser ray is reflected, it will use that information to measure the distance in that direction.
Donc, en fonction de... Le laser va envoyer des... Le scanner va scanner dans toutes les directions. Et en fonction de là où le laser sera posé, vous aurez des informations sur la distance, les angles, les obstacles, etc. par rapport à l'objet.
All right. And so that is captured in the ranges here. That is what you see there.
Et toutes ces informations seront capturées dans les ranges.
Okay. So if you see what it printed for us, let me run it again. There's a lot of data, but you can see ranges here. And ranges is very long because there are many data points. Most of them are INF. INF means infinity, means you didn't collect a useful data point there.
Donc, comme vous pouvez le voir sur le terminal, vous avez toutes les informations relatives à ce que le scanner a pu scanner. Et après, vous pourrez voir INF, ce qui veut dire infinity, ça veut dire infini. C'est-à-dire que dans cet intervalle de temps, vous n'avez pas forcément capté d'informations importantes.
All right, so I will, for the interest of time, I think it might be helpful to stop here. I apologize, we have gone longer than I planned, and I don't want to keep us too much longer here. I will go ahead and upload the rest of the code to GitHub, and so that you can look at that code and also try it by yourself. So I'll do that.
Donc, on ne va pas s'attarder sur le code, mais il va publier littéralement le reste du code et vous pourrez avoir accès sur GitHub.
Okay, but basically the next things to do would be to, in the think, next thing would be to write a think function that would take in scan data. Okay, that's the next thing to do.
Donc, par rapport à la partie think, vous allez sortir de la fonction qui a été définie, la fonction principale, et vous allez définir think, dépendamment des données qui seront faites sur le sensor LiDAR.
Okay,
Et
and
ensuite,
then you...
Et ensuite, vous pourrez définir la fonction act par rapport à la commande move qu'il est en train de définir maintenant.
Okay, yeah. And then we have act. Sorry. We have like a command. Okay, so this is pretty much what we need, something like this. And then we will, what you will see in the code is that you need to write the function for thinking that will process the scan data. And then for acting, that will process the move command data. And this move command data is coming from the thinking function like this. Okay, that's it.
Donc, le move command data revient de ce qu'il a défini précédemment avant la fonction principale. Voilà.
So I will upload at least a code that works. Remember, the goal for the code to work is that it will move the robot until it reaches maybe like 6 meters from the barn and stop. It's a very simple problem, but I wanted to use it as a way to explain to you subscribing, publishing, and some basic ROS Python ideas. Okay. I don't know if there's any questions. I can open up for questions now. If people have any questions before we wrap up this afternoon, you can answer questions.
Est-ce que vous avez d'autres questions avant qu'on ne clôture le meeting? Vous pouvez désactiver votre micro ou écrire dans le chat.
Okay, so I just uploaded I put the link again to the chat in case somebody missed it. I put that in the chat. If you are an experienced Python coder, you might think, oh, there are other ways that you can solve the same problem. That is very correct. Okay, you can use object-oriented programming. If you have experience with object-oriented programming, you can use that, and you can make classes. You know, there are other ways you can solve the problem, but I wanted to give the most basic way for the benefit of those who don't have much experience in Python programming.
Donc, pour ceux qui n'ont pas une grande expérience en Python, vous pouvez toujours utiliser ceux qui matchent avec vos connaissances. Et si vous connaissez aussi OOD, vous pouvez toujours utiliser OOD pour résoudre la tâche.
All right, so let me close this. My laptop is struggling. All right, so that is really where I think we can wrap up for today. Again, I apologize for taking longer time than planned. But hopefully some of this was a little bit helpful. Next week, we will continue on, I will maybe provide another example that is a bit more, let's see how we go. But I don't know if anybody has any question or comment or, yeah, any question or comment. Also maybe about the style of writing code with you, whether that is helpful. Any comment that could help us to know how best to do things.
Donc, désolé que la réunion ait pris autant de temps, mais nous espérons que d'ici la prochaine session, tout se passera pour le mieux. Si vous avez d'autres questions relatives à la session d'aujourd'hui, vous pouvez toujours ouvrir votre micro ou l'écrire dans le chat.
All right, thank you, Arnold. Yeah, I thought it was helpful. That's good to hear. All right, well, we're always on Slack. Okay, we're always on Slack to provide support for you. We got 5 people who have shared some of their challenges with setting up their computer. We will follow up with them. If you are here and you still have some challenge with setting up your computer, please put message in the chat right now, or after this session, please go on the PC setup channel on Slack and let us help you to find a way to get your PC set up. All right?
Donc, si vous avez toujours des problèmes sur la configuration de votre ordinateur, veuillez s'il vous plaît écrire dans le chat ou directement aller sur le channel PC Setup sur Slack pour exposer votre problème.
All right. Thank you. So if there's no other question or comments, I think it would be good to end this here. Thank you all very much again. Hopefully this has been a good learning experience for you. We're always happy to hear feedback on how these workshops are run. I know today was longer than usual. Actually, I planned to have a break in between, but time is always behind us. So we will try to improve in our time management next time. But if you have any suggestions or recommendations, we're always happy to hear from you on how we can better design this to be more effective for you. All right. Thank you all very much.
Si vous avez des recommandations par rapport à comment nous pouvons faire pour réduire un peu le temps des réunions, vous pouvez toujours l'écrire dans le chat.
All right, question about where to get the recorded video. Yes, I can show that to you right here. I will actually stop recording first.